Okay, we're going to be looking at Virginia Math SOL 8.2 subsets of real number. The word subset means it's below, okay? So like subway is below the ground, submarine is under the water. A subset are these number classifications that are below the one above it. So all numbers that you encounter are real numbers, okay? But there's more specific labels for a number. For example, North America is a continent, but you also have the United States, and you have the United States, and within the United States you have Virginia, and within Virginia you have Page County, and then within Page County you have Stanley. So you can get very specific with geography. You could get specific with music. You have country music, you have female artists, you have Dolly Parton. So likewise, numbers are also can be very specific. So one category of numbers are called irrational numbers. Those are decimals, okay, that do not end or have a pattern. So if somebody's irrational, they're over the top, like off edge, like you can't really predict their behavior. So likewise, numbers are not predictable, like 0.12579661. What's the next number? I have no idea. Or 0.3332149. I don't know what the next number is. Or even pi, okay? Pi, we use 3.14, but the real pi, the real number, you push pi, long decimal goes on and on and on. You don't know what the next number is. Is it a 9? Is it a 6? Nobody knows. Likewise, square roots, like 7 square root, gives me a very long decimal. I can't predict the next number. So all of those numbers, when you simplify those, of course, they give you long decimals. They're irrational. And this is kind of like a family cookout, okay? Families getting together. They're not including the irrationals, okay? They're the people that are the outcast of the real number family. So rational numbers are the most inclusive. They'll let the most people. Integers will let like your negative Nancy's in. Whole numbers, that one family member that I think we should invite in. And natural numbers, they're very selective. Okay, they don't let a lot of people in. So we're going to start with the selective, the picky people. Those are your counting numbers, okay? And they're positive, okay? Only the positive folks get in here. Your positive counting numbers. So things you can count on your hand, like 1, 2, 3, 4, 5, and so forth. You're counting sheep, all the way up to 98 or something like that. They're all your positives, okay? They're very exclusive, okay? Well, the next up are the whole numbers, okay? They are your natural numbers and 0, okay? They will let 0 in. That one family member, people are like, I don't know about them. They'll let 0 in, okay? By the way, natural numbers, just before I get ahead of myself, like the square root of 25 is 5. So you always have to simplify as simple as you can get something to get its original number, okay? So the square root of 25, because it's 5, would be a natural number. Okay. Remember, whole numbers include your counting numbers, but they also let the 0, that number not go in many places in life, they'll let them into their party. Okay. Integers will let your natural numbers in. They're like, yeah, you're invited to our party. They'll let the whole numbers. You can remember whole because there's a 0. Whole lets a 0 in. But also your negative Nancy's, okay? So your negative numbers, like -3, -7, negative square root of 81, which is 9, by the way. They'll let the negatives in, they'll let the positives in, and they'll let the whole 0 in, okay? Then you have your rational numbers. They're like, hey, y'all are being too exclusive. We'll let the natural numbers in. We'll let the whole numbers in. We'll let integers. But they'll also let plus fractions, such as 3/7 or 5/12. So any number that can be a fraction. And here's the most specific, decimals that end, such as 0.12, or have a pattern. We're going to carry this on down, okay? They have a pattern, like 0.31, 31, 31. The next number is going to be 31, or 0.22 repeating. Okay, they have a pattern. If they end or they have a pattern, they'll let them in. Okay, so again, this is like a little family cookout. Natural numbers only let the positive count numbers in, which could be 1, 2, 3, 98, or like the square root of 25, or 6 divided by 2, because that gives you 3. They'll only let whole numbers will allow 0, see the 0 and whole, plus your natural numbers. Integers allow the natural, the positive folks, the not going places, 0, whole numbers, and all the negative Nancy's. Rationals let all these folks in. See how they kind of eat the boxes here? Rational includes integer, whole, and natural. But they'll also let fractions in, and decimals that end or have a pattern. Okay? The ones that are excluded from the whole cookout altogether are the irrational. They throw their own party. They're decimals that go on and on and on forever. So let's look at this. We have a box here, and we're going to help classify each of these numbers, okay? So pi, it's not 3.14. Use the button on your calculator. It's a very long decimal. Natural, whole, and integer are not decimals. So we have to decide if it's rational or irrational. We already kind of said that, but because it goes on and on and on and on and on, it's irrational, okay? And real as well. All numbers are real, okay? 0.2222222, on and on and on. Again, it can't be these three because it is a decimal, but since it has a pattern, you know that, well, it ends as well, but if it went on, you would know the next number would be 2. It's rational. And again, real. Real is like the person you go to in the family, everybody's allowed to go to them. They don't exclude nobody, okay? 0, it's not natural because you wouldn't start counting. Let's say you're a teacher counting kids for a field trip. You don't go 0, 1, 2. It's not a counting number, so it's not natural. But it is that whole 0, okay? Integer, rational, and real. Negative square root of 25, again, 25 square rooted is 5, and it's a negative sign on the outside of that radicand, so it's not natural or whole because they don't like the negative people, but it is an integer, it is rational, and it's real. 16 divided by 8, so a fraction is division. 16 divided by 8 gives me 2. 2 is a counting number, so it's natural. It's whole because it's 0 or bigger. It's an integer, it's rational, and it's real. 7, it's a counting number, so it's natural, whole, integer, rational, and real. Okay. Now, here are examples of different style SOL questions. It says, the set of whole numbers, so basically whole numbers is not a subset of, so whole numbers is not part of. See, integers, yes, because integers, whole numbers are below integers, okay? real, all numbers are real. And whole numbers are below rational. So sub means below on our little chart, but they're not irrational, okay? Which of the following does not represent a rational number? So 0 is rational, okay? 2 1/2 would be 2 point, get your calculator, work that fraction out, 1 divided by 2, it's 5.5, so 2.5, that's rational. It's a fraction, it's rational. Square root of 3, long decimal, no pattern, that is the not rational one. So what I'd like you all to do now is go on to Cubbage and Power Test, Cubbage/Gershon, real numbers. Take that in Power Test. If you score above an 80%, you're welcome to move on. Otherwise, IXL. Okay? There's some IXL strands for you. Take care.